Have we ever wondered what truly drives the global weather patterns we experience every day? It isn't magic, it is a complex dance of thermodynamics. Today, we are diving deep into atmospheric dynamics to uncover the invisible forces shaping our climate. The Earth's atmosphere is a dynamic system that acts as a massive heat distribution engine. At its core is a massive heat distribution engine. At its core is atmospheric thermodynamics, where buoyant forces cause warmer, less dense air to rise while denser, cooler air descends, creating the vertical movement essential for all weather. This vertical motion is powered by a continuous cycle of water transformation. As liquid water evaporates into vapor, it releases heat, fueling the rise of air parcels. When that air cools higher up, condensation occurs, releasing latent energy that drives storms and sustains atmospheric pressure differences. But what makes air move horizontally? Convection currents combined with the spinning of our planet create a consistent global pattern known as atmospheric circulation. This interaction generates prevailing winds that transport heat from the equator toward the poles, regulating Earth's temperature. Within this circulation, scientists study complex phenomena like internal gravity waves and Rossby waves. These are massive undulations in the atmosphere that follow the law of potential vorticity conservation, acting as the steering mechanism for huge extratropical storms and shaping our day-to-day weather. Understanding these dynamics is crucial because they dictate how we assess climate change impacts. By studying air movement and tracer transport in isentropic coordinates, meteorologists can better predict short-term weather changes and model long-term climate trends with greater accuracy. So, from simple convection to baroclinic instability, atmospheric dynamics are the invisible architects of our world. They turn a static air mass into a living, breathing system that defines our climate and weather, proving that studying air movement is key to understanding our planet. Now you know the science behind the sky. Which weather phenomenon fascinates you most? Let me know in the comments and subscribe for more deep dives into atmospheric science.